Hello, everyone. Many thanks for joining the track on AI in data quality management. My name is Mattia Ferrini. I am a Senior Principal for Data Science and Engineering at Visium. And I would like to introduce the track by showing the opportunity for the use of AI in data quality. Data quality remains a challenge for many organizations. Gartner estimated that organizations spend every year almost $13 million in average dealing with issues related with poor data quality. Rand reported that around 80% of AI projects fail, and poor data quality is identified as one of the common root causes. So, why not using AI to accelerate and improve data quality management? Today's track will provide you some inspirational use cases about how AI has been used. The speakers will share their experiences and lessons learned, and the key success factors, what made those initiatives possible. After my introduction, I'm going to be happy to leave the stage to Renata from Philip Morris International. She's going to be talking about AI in customer data quality. Unfortunately, Elena cannot join us on stage, but a big thanks to her as well for helping prepare the material and contributing to this track. We'll welcome Maria from Lonza. She's going to present about the use of AI in data quality in pharma manufacturing. And I'm going to be describing a use case where we use the AI to boost data uniqueness and consistency at a large multinational organization. All these will be followed by a panel discussion where we'll give you the opportunity to ask questions, and let's have an exchange about AI in data quality. AI in data quality is a huge opportunity because AI in data quality is a Swiss Army knife that can help, on one hand, by improving data quality in every data processing pipeline. Data processing that takes care of structured and unstructured data sources, that takes care of internal data sources, as well as data acquired from third parties. But that's not just it. AI in data quality means also that AI can help democratize data. It can help extract metadata, and it can also help collect information that will improve the data documentation. I'm saying that AI in data quality is a Swiss Army knife because AI can address data quality issues across the entire data lifecycle. It can help integrate the data by identifying potential duplicates with a probabilistic entity resolution, but also can help understand how data from different disjoint sources can be merged, joined together. This is called schema mapping. Once the data is integrated, AI can also improve data quality by helping in the identification and in the resolution of issues. When it comes to the identification of issues, AI can help define and validate the data quality rules, but also complement the rule-based systems with anomaly detection, identifying anomalies with statistical analysis. Once issues are identified, can help in the remediation by improving and validating the rules for the resolutions, but also providing rules and a methodological approach to resolve data quality issues based on statistical models. So there are really many ways AI can help in data quality. It's a huge opportunity. The question is, why hasn't been adopted? And what are the biggest issues when it comes to rolling out AI in data quality initiatives? I believe that the challenges are originated on 5 common misconceptions. The first is that everybody's saying that data is the new oil. In reality, that's not the case. Data is not fungible, and data doesn't have an intrinsic value. Any barrel of oil is equal, and if I would drop a barrel of oil at your door, it might be a little inconvenience, but I think you would be able to figure out a way to sell it. That does not apply if I would drop on your desk a pile of hard disk containing data from an e-commerce website from 10 years ago. The value of data depends on what you make out of it, and that also means, unfortunately, that different use cases impose different requirements for data quality. And one of the challenges has been the organizations are not able to scale their data quality management system with the number of use cases. And this is one element where I can help. The second common misconception is that, you hear it here and there, bias can be removed. In reality, this is almost impossible. Just think about we as persons. There are so many characteristics about us. The race, the gender, our background and heritage, our education, our height, body type, hair color, favorite soccer team. And biases on how we make decisions might be influenced by pretty much like any of these. So there are so many biases, and we can control with protected classes only a few of them. Protected classes can be race, can be gender. It's very important to have them, but that does not exclude that there are other biases, and identifying them is really tricky. And this is where I can help. The third common misconception is that a lot of people still in the industry talk about data quantity, and they just say, well, more data the better. In reality, if we look, for example, at AI, algorithms don't learn learn much from the same or similar data points. So that means that having a lot of the same doesn't help necessarily algorithms improve. That means that the new data is very valuable if it provides new insights and it explores regions of a domain space where you don't have a lot of data. So AI can also help identify these regions of a domain space where there's not much data. The fourth common misconception, by the way, I looked at this presentation pretty much like 300 times. I just realized that in the title I have five common misconceptions, but here I'm talking just about 4. This is another cognitive problem that I need to address. Very interesting. Data does not have shelf life. You think that as long as you store it somewhere, this thing can be there forever and is going to preserve its value. In reality, data depreciates fast. And this is because you have changes in operations, for example, how data is collected and measured. You also can have changes in the economic environment, in your business, on how competitors operate. That means that data from 3 years ago, maybe 4 years ago, today, might be worthless. For example, the customer behavior and preferences has evolved. So the fact that data have a shelf life, it's very important to keep in mind, and AI can help identify trends and regime shifts that indicate that, things have changed, and perhaps some data should be considered worthless or should be given less weight.
So, are you ready for the next session? Fantastic. So, I'm very excited to be here today to share with you some insights on data quality for AI and also AI in data quality in pharma manufacturing. And this based in the context of AI solution that we've developed for manufacturing deviation management. But first, a fantastic disclaimer for all of you. So, in a nutshell, use my insights at your own risk, whatever this means. Right. So, maybe a short introduction about me. So, I'm Maria. I'm AI and automation solutions lead at Lonza with global operational excellence. And my role essentially is to establish and manage our portfolio of AI and automation solutions. And the goal of this, as you can imagine, is to address our technological gaps. Exactly. So, to my background, I hold a master's degree in drug sciences, which is, by the way, a fantastic degree in Basel. So now you know. That's all great. And yeah, I guess that's all that you need to know about me. That's enough now. So nowadays, we still have the words AI and Gen AI on the lips, right? Now, what tends to be somehow overlooked still today is the main building block of AI, namely the data, right? And this is actually the biggest thing to really understand. So concretely, the most important thing is that if you want an accurate AI model, you need accurate data. So, and how we call this in the data science community is garbage in, garbage out. So with a fantastic AI-generated picture that had still to be edited to make it look really understandable. But yeah, that's another topic. So let's dive into the use case. So Lonza is a contract development and manufacturing organization, meaning that we manufacture drugs. And for us, the most important, as for any pharmaceutical company, is the patient. So this is why we track our manufacturing deviations diligently. And here, so for this use case, so we thought actually, since we have a lot of data, well, no, actually we don't have deviations, right? But that's the best area to implement AI, since we have a lot of text, and in this way, we can essentially accelerate and support text understanding activities with AI. So how did we usually perform deviation track and trending? So the former workflow was, so essentially our QA expert gets the data set of deviations for a given time frame, a business unit and site, and afterwards he would then go manually accounting all the deviations that we have. So say, for example, okay, so how many leaks do we have, how many missing documentation, etc., etc. And afterwards, the QA expert would then go on with his report and document everything that he has seen. Now, obviously, that's one example of how we do this. This is not in all sites done in the same way, since we have sites of different sizes, right? But that's a high-level representation of it. So, and as you can imagine, so this categorization of the deviations can be, to some extent, be replaced by AI. So what we did is a very simple tool based on topic modeling algorithms to find for us the latent topics, aka trends, in our data set. So how this works is we would take the exact same deviation data set and afterwards submit it to the extremely intelligent AI, and the AI would come up with essentially two more columns related to which AI identified topic a given deviation was assigned, and the second column would then tell you, okay, so for this topic number 1, for example, the topic number 1 is defined by the most frequent keywords, or words essentially, that do belong to this topic. So, and for what do we use that essentially? So for exploratory analysis in general, not only for deviations, by the way, since this can be applied to any type of text, and also to identify subtopics that we don't have in the variables that we already have when we document the deviations at the beginning of the process. And in this way, our QA expert can afterwards, in the same way, document all of these deviations. While I cannot really tell you which algorithm we used, I can certainly tell you a very similar one. So for example, that's a topic modeling algorithm, LDA, it's called. And the idea is quite simple. So what happens is that for each given collection of documents or text data, we assume that each document is a mixture of topics, and each topic is a mixture of words. And the mechanism afterwards is that the algorithm iteratively assigns words to topics based on the probabilities of a word to belong to a given topic. And afterwards, over time, with all the iterations, we then are able to identify, okay, so this topic might be related to this type of words. And finally, the algorithm is then able to converge in the sense of, okay, so since, for example, here we have one document with 4 potential topics in it, and say, for example, well, maybe with the words from pharma manufacturing, it's not quite clear for all of you, but let's make an example with dogs and cats. So, for example, if we would have a topic related to dogs, the typical words would be bark, dog, ball. If we have a topic related to cats, we will have cats, ball, and I don't know what cats do, otherwise I don't have a cat. Doesn't matter now. And maybe a third topic about giraffes, which is not really something that might happen, but nowadays everything is possible anyway. And now, so if it's a text about dogs, obviously you will encounter a lot of words related to dogs. And then afterwards, the algorithm would say, okay, so it looks like the majority of the words are related to the topic dog, so probably it is a text about dogs. That's how this works. You can imagine that since you understand a bit more how this type of algorithms now work, that the data quality is really central to this type of algorithm. So why? Essentially, to have a better topic coherence. So for example, in the sense of we want to avoid typically the topics like that would be defined by the words the, is, where, 1346 QA batch. Like, fantastic. What does it tell me? That we have batches. Who would have thought, you know? Now, another example of an unmeaningful topic. What happened? Problem. A word that doesn't exist. So it doesn't help us, right? The other thing that can also happen if we have noisy data are so-called fragmented topics, so which would be the same topic, but since we have misspellings or different ways of documenting units, we would have the same topic but identified by the AI as 2 different topics. That's something that we want to avoid. Now, number 2, so data quality is also important for to prevent vocabulary inflation. You can imagine if we have a lot of synonyms like delayed, not on time, late for the AI, well, the AI doesn't understand that those words are the same essentially. So that's a secret. AI is not intelligent, right? So sorry for that. And the other thing is also that we have in our industry a lot of abbreviations and way of contracting words. So we could have things like ultrafiltration and diafiltration abbreviated as UFDF, for the AI, I mean, it's like fantastic. I mean, cool. Those are two different words, and it doesn't really help us, right? Number 3, replicability of performance across sites. So obviously, while that's a wish, and that would be an ideal world to have the same grade of data quality across all sites, which is not always the case. But obviously, if the data quality changes across the sites, so does the accuracy of the algorithm, and that's something that is quite sad. Number 4, better topic interpretability. What we have seen, and this is also not surprising, is that, for example, if we have German deviations in the data set, obviously the algorithm will think, hey, let's just put them all together. So that's how we end with der, die, Wurt und nicht des von ein. A fantastic sentence as a topic, I would say. So all of this, all in all, so the impact of noisy data is essentially that we wouldn't be able to focus on the most important phenomena in our data, essentially, which could lead to not the best conclusions, maybe even a challenging change management, which all in all would limit the value of our use case. And what do I want this? So what kind of noise do we have in the data? So misspellings, I guess you all know, and the worst is that everybody can from time to time make some, and that's the worst, because it is not something that is related to intelligence or not, it just happens, and that's the worst. Now, number 2, abbreviations, as said. So another one, I was very surprised myself, by the way, to learn that microbiology is abbreviated MIBI. It's like, cool, fantastic. For the AI, no idea. Number 3, so eponyms. So for example, when we tend to call our machines by their brand, or for example, by their ID, which happens also a lot. We also have incomplete descriptions or lack of information, such as, but QA wasn't submitted. I don't know what this means. Maybe the AI will know. We will see. Inconsistent formatting, that's also a problem. So as you can see, all the variations of material number, agglutinated words with numbers, unit discrepancies, date formatting, ID formatting, etc., etc. Irrelevant data. So we also have some HTML tags in the text. We also can have some metadata, encoding artifacts, etc., etc. Number 7, vocabulary inflation. Sorry. I've already discussed this one. Also, short text. So this happens too. So I've witnessed some descriptions that only had, for example, 3 words, which is quite challenging at times, I must say. But sometimes it also makes sense. Number 9, so repetitive sentences, such as, for example, we have in some sites specific documentation templates, for example, starting with what happened, what should have happened, etc. So obviously, all these deviation get grouped together, which doesn't help us in terms of meaning. And number 10, we don't have this, thanks God, but there's also potentially a risk of including emotional biases into the descriptions, but we don't have this. So that's fantastic. So now, what to do with all of this? So there are many ways of dealing with that. So obviously, regular data preprocessing. So this can include data profiling, identification of domain-specific artifacts, etc., etc. What we did, that's a bit maybe of a shame, huh? but this works. So that's a secret. Not really. So what we did is custom data cleaning. So we really went into, okay, so which synonyms related to the domain can we maybe simplify, etc., and what kind of misspellings do we have, etc., because all of the tools available in an open source way, for example, cannot know about ultrafiltration and diafiltration, for example. So this is quite difficult to identify these the noise related to these words, for example. But there are really very interesting libraries for that. So obviously, what we also did, this was standardization of the vocabulary with rule-based NLP tools, so like regular expressions, fantastic tool. Number 3, continuous data quality monitoring. So this is also something that is possible. So to for example, monitor the appearance of new n-grams. N-grams are, for example, a set of words, of 2 words, I don't know, like not on time, that's a 3 gram, for example. So now you know. Feedback loops from user pool. So this is maybe not always done, because maybe some people would like to stay very digital in a sense. But this is very helpful. So when you have your user telling you, hey, see, I've seen that we have this type of word that has appeared, you should include this into your preprocessing pipeline, for example. Improve the data at the data source. So this would include, for example, some rules in the ETL process. So this is also doable. However, for us, so we're using domain-specific tools, so this is maybe not always doable, etc., etc. But this really depends on the industry. Improve or update data management software. So that's something for us, maybe. We will see. We are discussing about this. And finally, process re-engineering. So this is something that data scientists and digital roles tend to maybe not consider, but to me, ultimately, if the result will be better if we find a new way of documenting our deviations, maybe this would help, and this would be easier. So in this context, for example, for us, what might be very helpful would be that we would replace our free text fields with drop-down menus, etc. So that's also something not to forget. AI solutions to improve data quality. So there's nothing new. I mean, Renata has said a lot about this, but there are some models for spell checking, for translation, for entity resolution, schema mapping, and semantic similarity models to find, okay, so which words could be replaced, which synonyms, etc., etc. So this is all things that are, well, can be AI enhanced or not, but they are there. So this is also doable. Now, the topic modeling tool that we've developed, for example, typically it can also be used to improve the data itself. So that's great. So while maybe from time to time, the initial use case for this AI-based tool wasn't really always delivering the wished for results. So say, for example, when we have way too small data sets submitted to this algorithm, what we can definitely do is to see, okay, so for example, this group of deviations are written in the same way. How could we maybe improve the way we describe this type of deviations? So yeah, LLMs. So it's still it's still a hype, but definitely LLMs have their place in data quality. So say, for example, as a writing aid for data entry, or also as an aid for rewriting of deviation descriptions. It can also be used as a tool for flagging uninformative wordings, etc., etc. It can also be used as an aid to understand from the topic modeling tool what the topics mean. For example, say you would have all of the, say, 30 deviations assigned to topic number 1, and you maybe don't really understand what the top most frequent words mean, so you could potentially ask the LLM, hey, look, I have all of these 30 deviations. What would you say that this topic is about? And this would be also a fantastic aid for more junior personnel, for example, that is maybe not as acquainted with our data typically. Also, as you know, LLMs are for summarization and translation. Maybe a short notice on LLMs, so this might save some lives. So LLMs have limitations, and notably in this context of this talk, so LLMs cannot do topic modeling. Certainly, they can summarize the content of a text, but they do not use these statistical methods to understand data, right? That's one of the things. A second is that LLMs might struggle with domain-specific words. This is definitely the case, since maybe the version of the LLMs that you are using was not trained on this type of vocabulary. Number 3, so they can't really replace the humans in data quality improvement, because you still have to have a human eye on it, essentially. So better be careful. And finally, there's some reflections regarding GMP compliance with LLMs, since nowadays we are discussing about transparency of the algorithms, etc., etc. The problem is that, so how do we describe transparency of LLMs to the regulatory authorities in the pharmaceutical industry? So those are all interesting questions. So maybe here something very concrete. I hope you can see it. But essentially, so on your left, those are the topics identified with the AI, but without all of the data pre-processing. And on the right, as you can imagine, the right one. So for example, the number 1, that's a topic that is defined by the words pH, adjust, value, meter, measure, low. Interestingly, in both data sets, this topic was found. However, in the initial data set, we had 164 deviations assigned to this topic, whereas in reality, there should have been only 2 assigned to this topic. Number 2, what we have in the unpreprocessed data set are some topics that don't really make sense. So for example, here, BR, batch, XXX sample, span. BR and span are HTML tags, for example. So this topic is really useless for us. That's the same for the example number 3, LI, UL, follow sample batch. Fantastic. With a huge number of deviations in this topic. Next, what we've seen are also topics that the algorithm could not find in the preprocessed data set, so cold room temperature excursion. And afterwards, yeah, so all of these examples are more or less very similar and illustrate essentially how important that is. And maybe the last one that's quite interesting. So we've also seen how in the preprocessed data sets we have fragmented topics regarding bioburden, test endotoxin sample results, for example. And this is all not so optimal. So what did we learn today? So I hope you learned something, but probably not. I hope at least garbage in, garbage out. So that's, if there's one type of AI-related idea or mantra that you can really use every day while doing anything in your life, it's garbage in, garbage out. And this would be nice that the entire world would understand this, because this is really the essence of AI. So if your data is bad, your accuracy and your models are useless, and those are seriously wasted resources. Afterwards, so as I discussed, so topic modeling can also be used for data quality improvements. Another item is that this is really nice to have all of these digital tools for data quality improvement, but really be careful with them. So we just never know. And at times, re-engineering the process might really be maybe the best way of doing this. And finally, LLMs have their limitations, so data quality is really important. Thank you.
All right, perfect. In the previous talks, we focused on traditional data quality issues and remediations. This session is going to be about data uniqueness and consistency at scale. Problem statement. A client, a multinational organization, had to integrate over 30 data sources while ensuring uniqueness and consistency across all those previously siloed data sources, while also enforcing complex logical constraints across all those sources. AI is something that helped in all that, starting with the data integration. So what does integrating data mean? You have a lot of data sources, in this example here on two, a banking core, a CRM. And in order to integrate them, you have to build a data model, understanding how the data will be squashed together. As part of this process, you need to identify all the entities that sit in all the individual data sources. In this example, for instance, you might have in the banking core a bank holder with all the associated properties. In the CRM, you might have a lead with all the associated properties. But this is not enough, because in order to bridge together the different data models, what needs to happen is that you need to build some entities that connect the bank holder and the lead. Those entities are going to be ontological. So, for example, a notion of a client. Ontological because nowhere else, and in none of the underlying data sources, you're going to find something like a client as defined there. But the client is what is going to connect the banking holder with the lead, because the client is somebody who might have a bank account and also a lead for the sale of specific products. Now, this is a process that is extremely time-consuming and requires the work of data modelers that understand the domain quite well, and there are also relatively scarce resources to find in the marketplace. And the question is really, how can things scale? Because if you have more than 30 data sources, you're going to end up having thousands of entities with well, let's say hundreds of entities with thousands of properties. And, well, can AI help? And the answer is yes. AI can help in multiple ways. The first way to help is by helping in the entity discovery. So there are algorithms that scan through the individual sources and figure out all the entities that you might find there. It's a set of methodologies that have been developed since 30 years. What is interesting is that now LLM can also help there and enhance the traditional entity discovery methodologies. The second way AI can help is by browsing through the individual data sources, but also bodies of knowledge that can be internal wiki or external data sources such as Wikipedia, and they can help build a knowledge graph. You've seen probably a lot of knowledge graphs in the field of medicine, pharmaceuticals. And having this process of building a knowledge graphs supported with LLMs can identify potential candidates for ontological entities. And therefore, you are able to pre-populate in the integration layer this semantic data model with all the ontological entities. This might sound purely theoretical, but actually this is something that is done in practice. And in this specific use case, that led to the automation of thousands of data modeling hours. The second way AI helps is by ensuring uniqueness and consistency. So what does that mean? It's something that we saw in the use case presented by Renata as well. You might have different data sources with different entities, different properties. You might end up having duplications. And you might have a manual resolution process, but this is extremely time consuming, and what you have is what you need is an AI system that can identify duplicates. The way it works is you're gonna have rows of data coming from the same data source or multiple data source, and you're gonna have a system that allows you to figure out the probability that the rows belong to the same entity. So in a nutshell, in the sample here is you have a client with the name Andrea, surname Weber, gender female, an address, and whether it's married or not. Automated entity resolution means estimating the probability that they are the same person if you know that they live in the same address, and understand how the probability would change if you know that Andrea, in this case, is a woman and not a male, and understand further, for example, how the probability would change if you know that Andrea is a married woman. So it might be some likelihood have changed her maiden name into her married name. Having better data means that you can improve customer services. You're not going to have cases, for example, inquiries to your customer service that are spread over multiple rows that in the end point all in practice to the same person. You're going to be able to improve the performance of all your sales and marketing targeting models. And it's also a hot topic, especially if you are a financial organization. You're going to improve your compliance. KYC is a big topic. The outcome, well, by employing automated entity resolution, the client was able to automate hundreds of hours. The accuracy was better, and the outcomes were improved across over 20 use cases, leading to business impact of several millions. We talked about uniqueness. If we look at consistency, again, it's something that Renata already discussed. So consistency. So if we talk about consistency, you have a number of systems. They might be tightly coupled. So for example, you have data moving from one system to another. And what you want to achieve is that you're able to identify issues resulting from the improper update of information in one or the other system. And this is an anomaly detection problem. And with anomaly detection, you can discover patterns, anticipate these issues, flag the consistencies, and prevent also compliance problems. If we look at the third topic, so the enforcement of complex logical constraints across multiple data sources, this is also, again, something where AI can help. The problem is as follows. You have a complex set of data sources where you have entities and where you have properties. And properties are related by a set of constraints. So, for example, you might end up having clients that register for a service. They approve to use a service. Then on an application layer, they sign up to, for example, a website to access information. There you have a sign-up date. And well, from a compliance perspective, you want to make sure that the sign-up date is always after the moment they register and they get approved to consume the web services. For example, some service offered on their e-banking portal. Now, this is something where AI can help because this is a super simple case, but in reality, a larger organization end up having to maintain thousands of these logical constraints. And with AI, you can progress with the logical validation of it. It's a traditional AI, but it's extremely effective to identify, for example, logical constraints which are not consistent. So a constraint might say something, another constraint might say something else, and you always end up having some problem flagged. You can also help identify automatically rules, and those rules could impact tens of entities. So in this example, you have only 2, but in practice, you end up having a chain or a graph or relationships. And managing this by hand is a nightmare, and often becomes an engineering problem that concerns and hundreds of engineering hours going into this. By having an AI managing these and by including these rules into your semantic model, so in the model integration layer, it's tremendous benefit. So in conclusion, AI can dramatically accelerate data modeling and data quality management at scale. It can help in the resolution of traditional data quality challenges, but it can also help with challenges that pertain distributed systems or systems where you're dealing with a lot of independent siloed data sources that need to be integrated together. So, well, thanks a lot. Was a lot from a presentation perspective. I see a hand raised. Maybe what we can do is we can set up the panel, which has the purpose of letting you ask questions. And then I will be happy to. Fantastic. Thank you. Thank you.